First, let's read the problem. Melanie was so frustrated about her physics homework that she threw her textbook out of her 5-meter-high bedroom window at a horizontal velocity of 11.2 meters per second. Starting 24.2 meters in front of the window, Mr. Cormier runs at a constant rate to save the book, and he catches it directly above his head, 23 meters away from the base of the window. Mr. Cormier is 6.5 feet tall. How long does it take for the book to fall into Mr. Cormier's hands, and how fast did he have to run to catch it? So now let's break the problem down sentence by sentence. The first sentence is, Melanie was so frustrated about her physics homework that she threw her textbook out of her 5-meter-high bedroom window at a horizontal velocity of 11.2 meters per second. The only information we need in this sentence is that the bedroom window is 5 meters high and that she throws the book at a horizontal velocity of 11.2 meters per second. Next sentence. Starting 24.2 meters in front of the window, Mr. Cormier runs at a constant rate to save the book, and he catches it directly above his head, 23 meters away from the base of the window. The information that we need in this sentence is 24.2 meters in front of the window is where Mr. Cormier was. We need to know that he ran at a constant rate, and we need to know that he caught the book 23 meters away from the base of the window. Next sentence. Mr. Cormier is 6.5 feet tall. This is obviously very important. And the last sentence is the question, so we have to consider all of it. We're going to take this problem question by question. The first question is, how long does it take for the book to land in Mr. Cormier's hands? So the first thing we have to do is draw a diagram. We know the textbook is being thrown out of my bedroom window, so draw a window and the textbook being thrown out. We know that it's being thrown out at a horizontal velocity of 11.2 meters per second, so we draw a line from going horizontally all the way to where Mr. Cormier catches it in his hands. The question is, how long does it take for the book to land in Mr. Cormier's hands? So we are not figuring out how long it takes to get to the ground, but how long does it take until Mr. Cormier catches it? We also need to label Mr. Cormier's height, which is 6.5 feet tall, how tall the bedroom window is to the ground, which is 5 meters, and how far away Mr. Cormier is from the window, which is 23 meters. To organize our thoughts in the best way possible, we're going to break up into a chart that explains everything that happens vertically and everything that happens horizontally. To be clear, I'm going to clarify everything I've written in the charts. For example, A stands for acceleration, VI stands for initial velocity, VF stands for final velocity, T stands for time, and X stands for displacement, which is also known as the distance something travels from point A to point B. So let's establish what we already know without doing any math, starting with acceleration for vertical. For acceleration for vertical, we know that it's 9.8 meters per second squared. Why do you ask this? It's because 9.8 meters per second squared is the force of gravity on any moving object. The textbook is falling to the ground without any outside forces, so it's going to have a gravity force of acceleration. For our velocity initial for our textbook, it's going to be 0 meters per second. This is because in our problem it said I threw the book horizontally, so it didn't have any velocity vertically. We do not know the final velocity without using any math. We do not know the time without using any math. And you may think we know the displacement because we said it's 5 meters. But let's take a look at the question. It says, how long does it take for the book to land in Mr. Cormier's hands? That's the displacement from the top of the window to his hands. Right now, we know the displacement from the top of the window to the ground. So we need to subtract the height of Mr. Cormier to find the displacement from the top of the window to his hands. First, we have to convert this 6.5 feet to meters. So, by using my source of the internet, I found out that in 1 foot, there's 0.305 meters. So, I'm going to take Mr. Cormier's height, 6.5 feet, and multiply it by 0.305 to convert his height into meters. When I do this in the calculator, I get that his height in meters is 1.98. Then, I have to take the displacement from the window to the ground and subtract his height. When I do this, it's 5 meters minus 1.98 meters, making the displacement between the window and his hands 3.02 meters. I then fill that into the chart. So with the use of very minimal math, that is all we know for the vertical side of this equation. So now let's move on to the horizontal solutions. For acceleration, it is commonly known that horizontally it's 0 meters per second squared. Why? Because our velocity rate is constant, so therefore there is no acceleration horizontally. The initial velocity was stated in the problem to be 11.2 meters per second. We don't know the final velocity, we don't know the time, but we do know from the problem that the horizontal displacement is 23 meters. That is all we know without mathematics for the horizontal side. So now, using all the information we figured out without using math, we're going to find the time, which is the answer to our first question. So if we move to these two equations right here, these are the two equations that are commonly used in physics. First, there is acceleration equals final velocity minus initial velocity divided by time, and displacement equals velocity initial times time plus half of the acceleration times time squared. So, using our chart in these two new equations, let's look at both of them and figure out which equation would be best to use to figure out the time. Let's take the first equation. Do we have acceleration? Yes, we do. Do we have final velocity? We don't. And we also don't have time. So that means there's two unknown variables, so unfortunately we cannot use this equation. So let's look at our next one. We have displacement. We also have our initial velocity. We don't have our time, but that is the variable we are trying to figure out. And that's the only thing used throughout the whole equation is those three variables. So we can use this equation. So now that we know what equation we want to use, let's rewrite it over here. Again, displacement equals initial velocity times time plus 1/2 of the acceleration times time squared. Let's break this equation apart into two parts. The first part is initial velocity times time. We know that our initial velocity is 0, and anything multiplied by 0 is going to be inevitable. So we don't even need this part of the equation. So now our equation is displacement equals 1/2 of the acceleration times time squared. So now let's substitute in what we know. The displacement is 3.02 meters equals 1/2 of the acceleration, which is 9.8, times time squared. Now we need to multiply 1/2 times 9.8 to get 4.9. Now using simple algebra, we're going to divide each side by 4.9 to isolate t squared. When we do that, we get 0.616. Now we need to take the square root of 0.616 to get time by itself. When you do this in the calculator, you get your time to be 0.785 seconds. Now that we've put this in our chart, we know that time for the vertical and the horizontal will be the same because it's not possible to have a different amount of time of an object going vertically than it is horizontally. So therefore, our answer to the first part of our question is 0.785 seconds. Good job. Our second and last question is how fast does Mr. Cormier have to run to catch the textbook? So in our problem, we found out that Mr. Cormier happened to be standing 24.2 meters in front of the window when I dropped the textbook out. We also know that he caught it only 23 meters away from the window. Therefore, we need to take 24.2 meters and subtract 23 meters to find the distance in which he ran. So let's do that. 24.2 meters minus 23 meters equals 1.2 meters. This then means that Mr. Cormier ran to catch the book only 1.2 meters. From our previous question, we still know that he has to get there in 0.785 seconds because that's what we found out the time he caught it in. Therefore, Mr. Cormier has to run 1.2 meters in 0.785 seconds. The question is, how fast does he run? We also still know that his acceleration is 0 meters per second because in the equation, it said he was running at a constant rate, which, like I explained before, means the acceleration is 0. So now let's look at our equations again. We have the first one, so let's see what we have. Acceleration, we do have, but we don't have the final velocity or the initial velocity. Therefore, again, we have two unknown variables, so this equation is not needed. Let's make sure the second equation does work though. We have a displacement, which we calculated was 1.2 meters. We don't know our initial velocity because that is our variable, but we have our time and our acceleration. So let's use this equation. As said earlier, once we have chosen an equation to use, make sure you always rewrite it above your work. So displacement equals velocity initial times time plus half of the acceleration times time squared. Let's think about this. Once again, our acceleration is 0. Therefore, when we put 0 here, this whole side of the equation is going to equal 0 as well. So we don't need any of that, which makes this equation super simple. So now we're going to substitute in what we know. We know that his displacement is 1.2 meters, which equals his unknown velocity times his time of 0.785 seconds. So using algebra, we have to divide it by 0.785 seconds on either side, which equals the answer of the initial velocity being 1.53 meters per second. Thanks for watching and great job.